Welcome to Computer Engineering 126, Lab 1. In this video, we'll be covering how to use the development environment that we'll be using in this course. This will include a brief introduction to C-Line, an overview of version control using Git, debugging using the built-in debugger, and unit testing with Google Test. So at the beginning of class, everybody took the FizzBuzz quiz, which states write a program that prints the numbers from 1 to 10, but for the numbers that are multiples of 3, print fizz, and the multiples of 5, print buzz. For the numbers that are multiples of both 3 and 5, print fizz buzz. From the results of the quiz, we saw that you guys had a lot of challenges with this. So there's a couple of reasons why, but we'll go into the overview of actually what this quiz was asking for. So we use this quiz as a way to see your guys' C++ knowledge coming out of Computer Engineering 30 and 50, the C and C++ courses taught here, as they state. We wanted to see where you guys were at coming out of there. Unfortunately, you guys weren't at the level that you should have been coming out of the course, but those two courses. But at least we can see now where you guys are at, and hopefully we can raise you guys up faster, get you guys up to speed faster, so we can cover some of the important things in this course. So FizzBuzz, the question comes from a interview question. It's used to basically weed out candidates. It lets the interviewer know if you know how to program at all. Because it's fairly simple to program, and we'll do that here in a minute, we'll program it, but it's fairly simple to program. But if you don't understand certain if statements or how an if-else structure works, or how you don't have to always have an else statement, then it becomes more and more complicated. So some of the reasons why this might have been complicated for you guys is that you didn't understand or know about the modulus operator or the remainder operator that allows you to test if things are divisible by 3 or 5 or multiples of 3 and 5. And you probably might not have known about atomic if statements. So just basically testing if a thing happens, then doing something, rather than our normal if-else structure, which is conditional, do something, else if, conditional, do something else do something. So let's take a minute and open up C-Line now. Let's just create a new project. So let's program this up from a brand new project. So we're going to call this FizzBuzz. We're going to use the language standard C++ 11, and we'll just hit create. So we've created our new program. We don't have to always show these at the startup, just so you guys know. So if you don't like the pop-up happening every time, you can disable that. So back to the program. You can see here C-Line automatically creates a main.cpp and puts a simple hello world in there for you, which will be helpful for this quiz. So let's write this out real quick of what exactly the quiz was asking for. So I'm going to open up my slides again and copy and paste the quiz question over. And let's just put this as a comment up here at the top. Alright, so we've got our FizzBuzz question up here at the top. So, write a program that prints the numbers from 1 to 100, but for the numbers that are multiples of 3, print fizz, multiples of 5, print buzz. Alright, so I'm going to show you guys the way that most of you did this. So we'll get rid of this statement up here. You guys mostly did for loop. Int I is equal to 0, so this is initializing it to 0. Your first value to 0, then we do I is less than or equal to 100. Less than or equal to 100, and I++. So that's incrementing from 0 to 100, which is wrong because we want to go from 1 to 100. So we need to change this I to be 1. Now some of you got stuck here and you just decided to print out the number. So let's just start with that. Standard C out I. So now we're just going to print the number. So let's just see what this output looks like right now when we run it. All right, let's see if I can even compile it. Well, I still gotta wait down here to build symbols. So when you first start up a program, you have to wait for C-line to finish building symbols for the project you're working on. So that's going through and finding all the calls to an object, all the times you've built an object and stuff like that, and it builds an entire symbol table. You look up your functions and stuff from the objects you're working with, so you can do text completion. So when that's done being built, we should be able to run this. The run dialog is up here, so you can select how you want to run it. So I'm going to be running build all, and then I'll be hitting this plus button here when I'm done building the symbols. So actually, instead of running, let's just start building a little bit more of the program. So let's test that first statement. If I modulo 3 is equal to 0, so that's saying that if the remainder of the operator and we whatever the number we're looking at, whatever I is, if the remainder when we're looking at dividing by 3 is 0, that means it's divisible by 3, which means it's a multiple of 3. We want to print I. Right? And we can do the same thing for 5. But I guess we don't want to print I, we want to print fizz, and we want to print buzz. All right, so let's actually switch this over to an else if. That's actually the way most of you wrote it. And then we have an else standard C out fizz buzz. This is what we programs. Also with some standard inlines here at the end. We'll deal with that in a little bit. So we'll do standard C out. That way, every time we run through this loop, you will print out a new line so we can see what the outputs are. I wish this would go a little quicker, so you guys wouldn't have to see all this, but it's okay. We'll just sit here and wait. So now we're saving, which is good. Almost done. There we go. Now we can run. So let's see what happens when this runs. So we're going to run fizzbuzz. Oh. Didn't like that because I have a typo. And we can see why it was running like that. So let's try to rerun now. It's now going to build and compile. All right, so let's take a look up here. So we're printing a number and then we're making it through these if statements and these else statements. It wasn't divisible by 3, so we didn't print buzz. It wasn't divisible by 5, so we didn't, or fizz, and then buzz. We have this else here that prints fizz buzz. So every time it's not a divisible something else, or divisible by either 3 or 5, it prints fizz buzz at the end. So that's not what we wanted to do. So how could we change this in the way that you guys were writing it? So some of you did an if I mod 3 is equal to 0 and I mod 5 is equal to 0. Then you'll print out FizzBuzz. So let's try running that. All right, so let's take a look here. So 3 is printing out fizz, 5 is printing out buzz, exactly what we expected. 6 is printing out fizz, fizz, buzz, fizz. Oh, 15. That's both divisible by 3 and 5, but it's only printing fizz. So it's getting stuck here. As soon as it hits this I mod 3 is equal to 0, so this first fizz, it's jumping out of this entire structure now. So it's jumping out of this entire structure, and now we're just coming here and we're printing that new line. So the way to fix this, most likely, or the easiest way to fix this would be get rid of the else statements. So let's just get rid of all the else's, and we'll run if, and then if, and then if. Let's see what happens then. Oh, look at this. So now we're printing FizzBuzz twice. This is printing fizz here, because it's divisible by 3. It's printing buzz here, because it's divisible by 5. And then because now they're both equal to it, it's also printing FizzBuzz again. So how can we fix that issue? And we also still have the issue of numbers getting printed first. Numbers should only get printed if it's not divisible of anything. But if it is a multiple of 3 or 5, then it shouldn't print a number at all. So one of the ways to do that would be to move this print statement out of the front, so out of the first thing it does. Instead, put it down here, get rid of this FizzBuzz, since we know it can now print FizzBuzz without having to explicitly print FizzBuzz. We're going to print out the number, and we're going to change these values. Instead of being equals to, we're going to do not equals to. So if for any reason it's equals to 0, or it's divisible by 3 or divisible by 5, it'll print out either of those. But if it's not divisible to either of those, or both of those, I should say, both of those, it'll print out the number. So for some of these, it'll do it right. But for others, it won't. Let's check it out. Actually, I think this does work. Let's run it. All right, actually it does work like that. There we go. 1, 2, fizz, 4, buzz, fizz, 7, 8, fizz, buzz. Yep. And 15 works. 30 works. 45 works. 60 works. Look at that, all the fizz buzzes work. So now what if we were to expand this to print out print woof when the number is a multiple of 7. So print woof when the number is a multiple of 7. So with a structure like this, all we have to do is add if I mod 7 is equal to 0, standard cout woof. And then we will also have to, down here, set this so if it ever gets to a 7, don't print out the number as well. So let's take a look and see what that looks like. All right. 15, 7, yeah, there we go. 7, so that is working. That was another way to write fizzbuzz without this woof part. So we just get rid of that woof part and say we're not doing it right now. There's a way to do this with nested if statements. And then we'll go back and we'll try to fix it with those nested if else statements with woof. So let's just comment everything out. Yep. Actually, before we do that, let's talk a little bit about debugging. So, like we saw down here, we were looking at this issue 15 printing out. If we wanted to just look at the program state at a certain time, where we saw there was an issue here at 15 trying to get buzz or fizzbuzz to print out, we can set a breakpoint and we can use our debugger. So you can set a breakpoint by clicking anywhere here next to the numbers to the left of this line in the IDE, and it sets a breakpoint that your program will stop at when you run your debugger. So let's just run the debugger right now and see what will happen. So it's going to recompile, and it's going to set up that recompiled program into whatever debugger is built into your system. So on Windows, you'll also get a pop-up here. That's your standard output. Instead of it being in the console, for some reason it pops out. I haven't figured out a way to get it back in, but it works. So let's just bring this over to the left. All right, great. So also bring that over. So right now we are just before this is instantiated, just before this line is run. So our I value right here is set to 1. So we just initialized I is equal to 1, and we're just now at the first instruction or the first operation in this for loop. So we're just about to execute line 13. We can step down and step through this line of code. And now we just did that first if statement, and we checked if it was divisible by 3, and it's not, so we didn't do anything. It wasn't divisible by 5, so we didn't do anything. And it's not divisible by either of those, just like we just tested. So it's going to print out a 1. I stopped running it. Let's try that again. All right, let's do this one more time. So let's jump down, jump down, jump down. There's our 1 right there. All right, so now it's going to print a new line. And now we just instantiated our I is equal to 2 now. And we can also see that down here. And we can run through. And we can see what the program state and all the variables that we've instantiated, what their values are the entire time. And we can see the output that'll happen when we run through it. Now something cool we can do is, instead of just having a regular breakpoint, we can have this be a conditional breakpoint. So we can say we want to stop here and only if we meet the condition of I is equal to 15. So we will only stop here when I gets to 15. So we stopped there, and we can see here that we did exactly that. We stopped when I got to 15, we finished the 14th loop, and now we're just here at the beginning. I is equal to 15. We step once more, it'll print fizz, it'll print buzz, it won't print the number, and it'll print a new line. Now I is set back to 16, it was incremented by 1, and we continue through. So that was the option of stepping over and setting conditional breakpoints. We can also run to the cursor, so I have the cursor there, I can run to the cursor and go all the way down to there. You can step into functions, but we'll go over that in other parts of this course, stepping into and around and out of. So if I wanted to, I could step into the standard cout function. I could force my way into that function. So let's force in, And now I'm in the disassembled C++, or disassembled, this one would be x86 assembly. And this is all the calls that are getting called on that when we do a cout. So I'm just going to close out of that disassembly and continue running. We're going to pop out, and there we go. So if you really wanted to, you could look at the assembly that's happening when you're running your program. All right, so we're going to stop debugging that now. Something else we're going to talk about right now is version control. So like we were doing with this woof up here, I'm actually going to explain version control as we're going along. So you're not going to be doing this for most of your assignments, but right now we're going to be turning on version control. We're going to be enabling version control for this project. So we go here, I'm going to select Git as my version control system. And this is going to both initialize a repository. A repository in your system is a place where all the code is stored. All the changes of your code is stored. All the messages about changes of your code are stored. Basically, the entire history of the project and that code is stored on your computer. So right now I'm initializing it, and we can see here that none of these, so I've just initialized the repository, and I need to add the files to the repository. So I'm going to click here, I'm going to come down here to Git, I'm going to click Add. So anytime you see a red file in your file tree, or here on the top in the tabs, that means it's not in your Git repository. We'll talk about the repository here in a little bit and what this all means. I'm just going to set this up real quick. All right, let's go back to those slides. So we finished the FizzBuzz quiz and challenge, and we'll talk about a little bit about making the woof, but we're going to talk a little bit about debugging as well. Yeah, we can do conditional debugging, we can look at the entire thing, we can look at all variables, we can set conditionals, we can change variables. I'll also show you that in a little bit. Yeah, it's really, really cool. So version control. This allows us to work with other people on the same code at the same time. You guys probably haven't had anything or any like group programming assignments where you have to work with multiple other people to write code or other things like that. And if you have, the ways you probably have done it are either via email or through a USB flash drive or using an online service that lets you have like a Google Docs style like notepad that just has code in it and maybe has syntax highlighting. Or you could instead save files to something like a cloud storage service like Google Drive, Dropbox, OneDrive, or Apple Cloud. But we're going to be using what everybody in the industry uses, which is a version control system that's specifically made to do code storage and code versioning and things like that. So we're going to be using Git, but there's other ones out there too, like Mercurial and SVN. Some of those are a little faster for certain applications, but Git has, I think, 70% of the market share in terms of like code bases using it as a version control system. So it's the one to learn if you're going to learn any of them. So what version control allows us to do is it allows us to save our code, compare the changes to the code, revert changes, branch, merge, just a whole bunch of different things with the versioning of the code. So every time you see a version of something, like you need to download a new Chrome update, or I guess they're automatically done now, but if you have any piece of software on your computer that asks for version or to update, that means a new version of the code is released, and you need to now download those changes on your computer. In this case, the people that are writing the code, they're developing the software. Once they get to a certain set, either time or amount of changes fixed or bugs fixed or something, they'll then release that version. They'll stop working on that specific version, release that version to you guys, and they'll start the next version. So that would be considered a branch. The other nice thing about version control systems, other than just branching and versioning actual version numbers, it's all stored in a central location. So multiple people can work on the file at the same, or the program at the same time. It's not just a single file. It's the entire system, the entire program that you're working on. So if you're working on a giant program, it could be millions of lines of code, and the system can deal with that, and it can deal with thousands of people all working on the same stuff at the same time because of the way it's written and how it's all decentralized. You may have a central location that you send your code to once you're done, but every programmer also has a copy of the code at the same time. So let's go a little bit over the terminology. So a repository is where your code is stored. So it'll both be stored on your computer, like I just said, but it'll also be stored up in the cloud or at a remote, which is what a remote repository, or what a repository that's not on your own computer is called. It's called a remote. In this case, your remote will be using bitbucket.org, and we're using that because it allows for private repositories, it allows for your code to be private, and we can't allow your work in this course to be public. It's just an academic thing. You guys have to be honest with each other. You can't be cheating off of each other. So this allows for us to do private repositories in the cloud and save your stuff in the cloud. The other nice thing about version control is that if your computer ever dies, or for any reason you lose your computer, or your code is deleted, there's always a copy of it in the cloud as long as you're pushing your updates up to the cloud. So now let's go to commits. So every time you make a change, like a significant change, like you wrote a function or implemented some operation or fixed a large bug, you should commit that change. And commit means you just say, this is the stuff I've changed, here's a message of what I've changed. Save a snapshot of this right now. And so that's going to save a snapshot. It's going to increment your version number or whatever, and that is saved. So you can revert back to a state previous to that, or you can revert to exactly when that happened. So that's committing. You're saving your code. Polling is where you're getting your code from a remote location, so some other computer other than your own. So that's like if you're working with a couple other people, you're all pushing to the same location, and now you're going to pull that code and work on it together, or work on it independently. So polling is getting code from the internet or getting code from somewhere other than your own computer. Pushing is sending your computer or your code and the changes to your code to another location, another remote location. So like Bitbucket is where you're going to be pushing your code to. And merging is what happens if you wrote something in the code and somebody else wrote something in the code and it changed between the two. Now you have to merge those two changes together, and a nice little dialog box will pop up, and you can select if you want to keep your stuff, or you want to keep their stuff, or you want to keep both of them. It's in C-Line, it's very nice, but this merge functionality lets a whole bunch of different people work on the same code base and make changes to it, and all work and figure out how to make things work together. So those are the 5 main things that you need to learn about Git right now: is repositories, committing, pulling, pushing, and merging your code. All right, so let's go back to C-Line. So we just set up a new repository. So our repository is now initialized with the CMake file, list, which is our just standard build environment, like a make file. It just says, oh, this is the project name, this is where to find the file, main.cpp, and we're going to compile it using C++ standard 11. Right? So let's go back to our main. So we've initialized both those files in the Git, but now we need to make a commit. We actually need to put the files into the version control system. So we're going to make our first commit. We're going to come down here, we'll look at main.cpp. And so you can see the green lines. So if everything's green, that's the new stuff you're adding. So that's all the new things that are getting added to the program. So for this first commit, we're just going to say initial commit, because it's our first commit into this version control system, or this version control, this Git repository. So it is now committed. So we have now made our first commit. So if I change anything, like let's say I want to implement whoop, if We're gonna do it a little easier than that. I'm gonna come up here. So let's implement woof without the final thing. We'll just see. We'll find this bug. So let's get rid of that breakpoint. Let's just run this now. See what happens when we run it. So let's look at 7, woof. Oh, see, yeah, we're printing out 7, woof, and 7. So that's not good. So let's just take a look like we were doing before. Let's reinforce our debugging skills. Let's set a conditional breakpoint when I is equal to 7. All right, so we've got our conditional breakpoint. Now let's debug this again and find out why it's printing a 7 out at the end. So it wasn't fizz, didn't print out buzz, because those are neither divisible by 7 is not divisible by 3 or 5. So now we're at woof, and it should print out woof, and we can see that here. Woof just got printed out. And now, oh, it is divisible, so that's where our issue is happening. We were printing a 7 out here. So we can figure that out, that this is where the 7 is getting printed out. So if we want to change this, there's a couple of ways we can go about this. First, we'll stop compiling right now. We'll stop debugging. Let's come here. Let's do those double ands and 7. It's not equal to 0. So this should fix that issue we were running into. Let's run that. Look at that. All right. Awesome. So our output's working. So we implemented woof into our fizzbuzz woof. Let us commit that. So this is where we're actually doing a commit. So let's look and see what our commit message looks like, our commit dialog. So blue means change and green means add. So we changed this line and we added this green stuff right here. So that's highlighted green. We added that. We also added this line up here. So we can say fizz buzz woof, or I guess we say added woof functionality to fizz buzz. All right. So we have committed those changes. Now let's take a look at the history for this file, this main.cpp. So we can come up here and we can click show history. This will show us all the commits that have ever happened on this file. So we can see here the first commit, the initial commit it says here, was we added all these files. The second commit was us adding this line, line 15, and adding this part to line 16. So it shows exactly what changed, which is nice. Now let's say we wanted to go back to fizzbuzz. We can come here, like getting rid of the woof. Instead of just deleting stuff, we can come here and we can click I just want to check this one out. I want to it's not what I wanted to do. I want to check out this older one. Refresh. I think I can do it from here actually. So git doing already. All All right, we'll talk about that a little bit later then, reverting to a previous commit. I believe it was just it's that one. Oh yeah, okay, so it's git. So you can swap back to a previous version by using git. So we're gonna jump back to this one. We're gonna modify that. Yeah, just accept the modification. So we are now back to here. So we've got our woof. Now let's say for some reason we got some of this got deleted, and we now have a syntax error and it won't compile. It won't run at all. We don't know what happened. Just something changed in our code and now everything's breaking. We can go back to our previous commit that we did and revert it, and it'll go all the way back to what we had previously. So anything that got deleted will come back. So we can do that again. We can delete this stuff. Oh, it's not running anymore. Let's just revert back to what we had previously. Isn't that cool? I think that's awesome. If anything's ever broken and it's not running, you can just go back to where it was last running. So that's another thing with committing. You need to make sure that when you're committing good code. You can't be committing things that don't work, because if you do, then you can't use this awesome feature of reverting, because then it defeats the purpose of going back to a previous version of the code that worked. Also, if you noticed, you don't have to comment stuff out anymore. So you don't just have to sit here, I don't want to use this anymore. I'm gonna copy this line and copy this line and remove the if 7. And now we're back to FizzBuzz. You don't have to do that, because you can just revert back to the state where it was just FizzBuzz. I think that's pretty cool too. So you don't have to do all this commenting. Yeah, it's a lot nicer. All right, so we went over committing, version control, debugging. Let's now pull the labs that you're going to be doing, or the repo that you're going to be using for this lab. So in order to do that, let's look at the actual assignment, so the actual labs. So this is what a Bitbucket online repository looks like. That you can look at it, you can look at the commits over here on the right side. You can look at the README. There isn't one here, but there will be at some point in the future. Last time it was updated. The URL up here, how to get it onto your machine. We can come over here and look at the source code. This is going to show us a file tree, so we can see that there's a couple folders, main.cpp and some CMake lists. We can look at all the commits that have ever happened on this. So you can see Brian and me have been writing some code for it. And branches, we don't have any branches. Most of the stuff down here we're not really going to be dealing with. So we can go back over here to the overview. So this is what it'll look like most of the time that you're looking at stuff. So let's copy and paste this link up here. This is the link to the repository. That is what you're going to be using to get this code onto your computer. So you're going to copy that link. You're going to come up here to VCS, stands for Version Control System. You're going to come down here to check out from version control. You're going to click Git, and you're going to paste that link without that overview. As long as you grab this, just by clicking up here, you grab that link, you should be fine. So paste that link into here, click test. It'll test if you can go to it. Connection was successful. That's awesome. And we're putting it directly in the default CLines project folder. We're putting it as the name that it already is. Now we're going to clone. So this is pulling all of those files down to our computer. So we can actually come here, CLine files, and now we have a folder in our CLine projects that has all those files in it. So we do want to open this and look at it. So we're going to click yes. We're going to click this window. So that FizzBuzz stuff, we're not gonna deal with anymore. So right now it's indexing, a simple thing that we did previously with the FizzBuzz project. But we can come over here and we can actually look at the file structure. So let's talk about the file structure a little bit. So we have two main folders. We have the library folder, lib, and we have the test folder. So let's go over the library folder real quick. This is where each of your labs are going to be. So right now we just have lab 1 in here, but it'll go all the way down to lab 10. And in the labs files, there's an include and a source. So all your headers go in the include folder, and all of your CPP files go in the source folder. You have to make sure they go there. This is the file structure we're going to be using for this course. It's a fairly standard file structure used in software development, so it's good to have you guys in a larger code base like this. By the end of this class, you'll probably have somewhere upwards of 50 files that you've written. So this will help you guys track where the stuff is and make sure it's all in the proper places. So that's what the lab structure folder looks like. Now let's take a look at this test folder. So this test folder is what's housing the Google test environment. So let's take a look at those tests right now.
On the website guru99.com, they say,
okay, Google,
testing environment.
Stop. I should have probably turned that off. It's okay. So right now we're looking at the test suite that we wrote for this first lab assignment. I'm actually going to open up these as well. So right now you can see there's all this red stuff. It's also not going to build. So we also got to add a build environment to this. So let's come up here, set a configuration. Let's add a Google test. It's going to be labs main. Actually, no, before we do that, let's reload this CMake list, this main CMake list in the top level directory. See the CMake list right here? We're going to reload the CMake project, and hopefully this is going to fix our issues with gtest not being found, expression.h not being found, testing not being found, all these different things not being found. We can also take a look at this CMake folder. Looks like all this looks okay. Let's come back over here to the tests, and we'll just see if it just nice and simple, all the red goes away. Right, while we're waiting for the CMake project to load, let's take a look at some of these tests. So for your code in this class, you'll be running it through a system of these tests, or each of these fixtures, fixtures similar to this for all of your code that you write. This is what we call automated testing or unit testing. So it's running this code. So come back up here. It's going a little slow. Okay. It finished reloading the symbols, and here we go. Stuff is starting to get. It found gtest. It found all these expected equals. That's good. Found the expression stream. But did it find gtest? Maybe not. Let's scroll down a little bit. No, it didn't find it. Let's reload the CMake file one more time. All right, so this first lab, you guys are just going to be writing tests to this class that we wrote for you guys. This class is a string parser that parses arithmetic strings to turn them into an array of characters, or just finds the next string or the next chunk of the string that it's looking for. So you have a couple operators like find next integer, find next operation, line next integer, and a line next operation. but your public functions are get next int, get next operator. So when you're using this expression stream class, you're going to have the two functions of get next integer and get next object, and we'll look at that here in the tests. So we've got stuff like this: stream1 is equal to this string, so we can come back here and look at the constructor. Here's our constructor. We're creating some buffers. Yep. So we're putting in a string of 1 plus 2 plus 3. And now we're testing that. We're looking for that first integer, second integer, third integer, and we're expecting 1, 2, and 3. And we're looking at the operators, we're expecting pluses. Just 2 pluses. And we got those working. Awesome. Now we're looking at these next set of tests. This is all testing stream 2. Let's look at stream 2. Stream 2 is 1 plus 2 times 4 plus 2 times 3. So we can see our next integers, 1, 2, 4, 2, 3, which is what we're expecting. 1, 2, 4, 2, 3, plus times plus, plus times plus, left parenthesis times right parenthesis, left times right. Awesome. So that one works as well. And this third one is doing negative numbers, either at both the beginning and at the like right next to an operator. So it can support plus, minus, minus. Awesome. So this just tested all that functionality right there. So this is testing just the basic stuff. We can also test the next stuff. So this is testing if the expression is complete. So we can look up here at this expression complete function. Another thing we can do while we're using CLine is we can actually jump directly to where these are getting declared at. So we can go here, we can go to find usages. We can actually see where it's getting constructed at, or we can even come here and we can go to, and we can go to the definition, just the definition of the object. So we're here in the CPP, it returns this. This is exactly what the function is doing. And this will jump us to the header. So these right here, these double arrows, jump you between the header and the CPP. So if you don't know exactly where something is declared at, you can just jump between them. If you want to jump to somewhere like the declaration of something, it's like, let's say I want to look at the get next operator, go to declaration. It'll take me directly to the declaration of that function. Really, really awesome to be able to jump around the program like that. And that's what the building symbols that was happening down here, that's where that comes from, is it takes the time to look through all that stuff and create these links right here. All right, so this is testing the isNext functionality. And now you guys need to write a couple of tests. So let's run what these tests look like and just see kind of what's happening when we run this. So we're going to run the basic tests. So to run them, you have to come to this drop down, select run basic tests, and then run. So it's going to compile it, and then it's going to run it through Google's test suite. If you're running Windows, you'll hit this sometimes. The way the MinGW and Google Test work, Google Test use some things that aren't supported in MinGW's runtime environment. So this will happen every time you run gtest for the most part. So we're building, and now we're running. It shows that all tests are passed. So if you see this on a lab assignment or an exam or something, that means you're good. You're going to get 100%. If we change some stuff in here, so like let's say we're expecting this 2 now equal, or this 1 now equal 2, so now it's expecting 1 plus 2 plus 3, or 1 plus 2 plus 3, which is not what it should be expecting. What we can actually see it break, and we'll see where it fails and why it failed and what it expected and what it didn't expect, or what it received, I should say. So we've got a 1 and a 2. So it was expecting a 2, but it actually got a 1. So that's really helpful in understanding why stuff isn't working. You can also see here the tests that are failing. It'll have a little plus thing. So if you just want to run that single test that's failing, you can run just that single test. So let's switch this back to a 1. Awesome. Great. So then when we switch that back, it should continue to run again. So this test suite just lets you see if the stuff is running properly. So for your assignment, you're going to be writing a couple more tests that are testing the functionality of this class. So this is going to require you guys to really read through the class and understand what the class is doing, both the header and the CPP file, and then write tests to test the functionality of that. You're going to be writing 5 tests. So this right here is a test fixture. You're going to be writing 5 of those test fixtures. Each of these is just a logic test that happens inside of it. Now there's tons of different types of tests you can use, logic tests you can use. So for the most part, we used expect equals to for this test. But you also have expect false, expect true, you have expect not equal to. And we could say that not equal to 2, so this test should now pass down here. But if you just want to see like a list of what all you can type, you can just start typing expect, and then you can arrow through here and actually look at what each of these do. So like greater than or equal to is what GE stands for, greater than, less than or equal to, less than, not equal to, near. That one's a little cool one where if you're dealing with stuff where you want it to pass, a lot of the time if it's like near a value within an error range, then you could pass it. Like if it's within like 5 to 10 of something, it won't fail. But if it's with like way outside of a range, then it'll fail it. But there's tons of different tests you can run. So play around with some of them, and that'll be your assignment for this week. And it'll be due on Tuesday. Tuesday the 6th, before lecture starts. So that is the end of this video, I believe. The next video, we're going to talk a little bit about how to set up Bitbucket and how to start sending your code up to Bitbucket. But yeah, this was a little bit of an introduction to your testing environment, your libraries, how C-Line works, how debugging works, a little bit of how version control works. Yeah. All right.